Hi, welcome to the Node Lifecycle Working Group. Today is December 12th, and we have one topic on the agenda. So first, do we have any new introductions or updates? Okay, let's take the first topic. Ryan, do you want to share your screen?
Yeah, I'll
Okay,
grab it
cool.
from. Okay. Okay. So I wanted to review um, a few things from KubeCon several weeks ago, and I wanted to review it in the context of the declarative no maintenance cap and some of what we've been talking about in specialized lifecycle management. And I think there were some really good discussions that were at KubeCon, and so I'll highlight a few of them. I think so. We had that. The Maintainer Summit presentation that Philip and I did, and there were some really good questions. And one of them I want to bring up was the question that was brought up. The question was, what is a node? And the context for that question, I think, is interesting. I think to think about um, the node and sort of or the reason for the question, I think, is that the node is changing in some ways, and sort of how we think about it, and that's really important for how we look at doing maintenance on this thing. And I think the way to think about it is with DRA taking hold in the community, there's been a bunch of thought around like what constitutes a node. And for example, like if you look at DRA today, like DRA will gives you a way to allocate devices, and it does it by advertising devices directly into the scheduler. And a device is really like a general thing. Like we can do a lot of things with this framework with DRA, where I think it was at least the main thing it was thought of is that, well, we'd want to advertise like a GPU, but it's so much more than that. And I think that's sort of like where this question came from, like what is a node, is because you could also allocate or advertise other things like memory or storage or CPUs. And these things are like native in Kubernetes already on objects. And so a lot of the things are changing. And maybe an even more interesting one to think about is like with the consumable capacity of DRA, there's this concept that you can advertise and consume bandwidth from like a NIC or from like a switch or maybe ports from a switch or something. And and so like when you think about all those things, like when you take that question, what is a node? Well, if you're like something like a switch, right, is not really a node anymore. Like we're basically decompose the different resources that we want to allocate to a pod, and we're bringing that into a scheduler, and 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 that's like how we're looking at some of the scheduling. We're looking at a place that has all of those decomposed resources, and so it's kind of interesting to think about in that context, because if we were to do maintenance on a node, we know what a node is, but if we're doing scheduling based on things like bandwidth, right? How that's another resource that's being picked in the scheduler. How are you doing maintenance on the thing that's providing you bandwidth? That's not exactly a node anymore. That's something else. So there's sort of an interesting question here about scope in terms of like what is the how do we want to target these caps, like so that we can really fit into this line of thinking that was really prevalent at KubeCon. So I don't really know the answer to that, but I think it was an interesting. It was definitely going through my mind while we were at KubeCon, and I wanted to have that, continue that discussion here. But is there any thoughts or questions or comments about that before I go to the next thought here? If you want to add anything, Phil, did you have anything what did you think?
Yeah,
Did you have a
just
similar reaction?
yes. So like you're right that like skip scheduler tries to like mm, I mean allocate or like set a target on the node where which has all these resources for a pod. So and it might not be even a node, but we funnel like everything through the node object in like the scheduler. So like in the end, you always like the scheduling is decided based on the node.
Yeah. Yeah, that's totally true. And I think which I think like so like the answer to the question, like what is a node and sort of the context that it was asked when we were talking about declared node maintenance is kind of like what you're I think where you're getting at here, which is like we still need to do maintenance on nodes. Like that doesn't really change. Like we would still want to do maintenances on nodes. Um, but like a node, but what is a node has, I guess, has changed in the sense that there might be other things that we'd want to do maintenance on besides a node, like a switch or I don't know, maybe a device or something. Like it's the scope. So I guess the way to put it is that, or way I'd put it is that maintenance isn't exclusive to the node API. That there are other things that we would want to do maintenance on. At least that's how I was thinking about it. But a node is one of those things.
Yeah, I agree. Like it's a good introduction. Like we shouldn't name the object node maintenance anymore and have like a way to extend it or like dynamically scope like the target of the maintenance.
Okay. Yeah, I think so. So that's kind of what that was kind of my takeaway from KubeCon. Yeah, and I think um so the second topic, like the scope, we're kind of getting into it. It's like so like the scope. I feel like it changes a little bit. Like we kind of look at it as like we node is a use case for maintenance, like doing maintenance. Node is one of the targets for doing maintenance, and there are other things that we want to do maintenance on. So the scopes changes slightly. So a lot of the things that we were talking about in declared node maintenance, I think, will definitely apply. I think really the open question in my mind, and kind of what I'm thinking about next, is like, what are ways that we can, with the scope changing, like what are ways that we can do maintenance in the general sense? Like how would that look? Like um, what would change? Again, I don't know the answer to that. I mean, I think it's something I'm thinking about. Yeah, go ahead.
And even though it's not well defined like in the cube, like but usually there is some kind of a machine behind the node and a lot of hyperscalers and like other components in the ecosystem like work somehow with the node. And this is like one of the cases like we can use and like to implement first and build up on that.
Yeah, I like the idea. I think so. So one possible direction, and because I definitely agree with that point. Like we should focus on the node. I think like that's already a known API. We already know we need to do maintenance on it, and it's already generally useful if we were to provide an API to help us do maintenance on it. So it's definitely, I think, the focus. So in terms of like scope, or I guess one idea that I have for the scope, or the scope, but the direction of this, is that maybe what we could do um, is look at this idea of doing planning. Like we take this idea and we say, okay, well, we want to do maintenance, and we want it to be declarative, and we sort of look at it, considering our scope, we say, well, we let's try to do let's try to do some planning. Um, so what does that mean? Like it would mean that I'm planning some sort of maintenance. I'm planning maintenance on something. And the something that we'd focus on first would, as a use case would be a node. It'd be like, I guess so it'd be one of the focuses, but it wouldn't, if you looked at it at this way, planning, the idea of planning, planning maintenance, it would be agnostic to these other things. And it would allow us to, I think, go in the direction of trying to solve the same thing that declarative node maintenance was trying to do and providing an API. But it wouldn't be specific to a node, like we would just be, node would be one of the use cases. Any thoughts about that idea or any disagreements or?
Yes, sounds good to me. I mean, like we certainly have to cast or show the whole picture. Uh, but for example, like what we see now, like with the eviction request cap, is like that we need to like target one, like the simplest concrete example we can ship, and like then ship it and have like an open path or like building on top. I mean, like the exploring all the like the possibilities is like very valuable because we don't want to get into the state like we have now with the declarative non-maintenance, but where the API is very limited and basically targets only the node drain. Like we want to have the ability to model all the like other cases for maintenance.
Yeah. Okay. Yeah, we want to model them all. Yeah. So I missed some of what you said. I was typing there. So does this meet what you were saying? Like I was saying is we would do. I wanted to take the direction is like focus on this idea of planning, we call it like planning maintenance. And then, but the focus would be like on like how can we do planning maintenance for a node? Is kind of what I was thinking. Okay.
Yeah, yeah. I mean, like let's like build the API like in the like most concise manner and like but have like the section which explores like the additional use cases where we maybe extend the API, but like when we first look at the API, we should have like the simplest approach like we can ship.
Okay. All right. That makes sense. Okay. Um, all right. So this is something I can take. But this is what, if there's no objections, it's kind of, that's something I'll start looking at how we can do that. Um, okay. Yeah, there's another hand. Go ahead.
Yeah, sorry. And one of the cases for the node like which we want to target is like the graceful node shutdown. So like we want to like have an option to model that behavior because this is one of the things like we would like to have and support.
Yeah. Yeah, so I agree. I think that's like how we prove that our thesis here, like if this is the right direction. So the node and then the graceful node shutdown.
Yeah, I suppose also maybe the like the keep cattle drain, but this can be like we can still talk about like which kind of which portions will go first in and so we might not do these both at the same time, but yeah.
Okay. Okay, that makes sense. Okay, so the third topic I had, I think we exhausted the first two, uh, is the bigger picture here. And I'm not really tied to this, and I just put together a picture. This was actually something I drew while I was at QCon, like my reaction to the conversations. I'm not really tied at all to this picture. It was just an idea to see like how we can like what does the universe look like when we were talking about like this. If we think about this idea of planning and we scope it to like a node at first, um and then we some of the use cases we talked about with SLM, and then we talk about eviction requests. Like what is the what does it look like if we were to build a picture around this? So I'll show this like idea, like, and explain some of the inspiration for this. And like I said, I'm not really tied to this at all. It's just like an idea that um I had. We can throw this out if it's not doesn't make any sense. But
Ryan,
yes.
can you please make the picture bigger or like put it into the presentation mode or
Yeah, let me see here. Okay, does this look any, let me see if I can do this.
yeah, this looks better. Oh,
Okay. Oops, I can't even fit the screen now. Okay, let me try this.
yeah, looks nice.
Okay. Um, okay, so I what I did here is I kind of took some inspiration from a few things. I looked at DRA and I was like trying to find some ideas of like how do we get how do we advertise things to to the kubelet and to different resources and get them like all tied together. So I looked at DRA a little bit and um, this model that I put here and is based on is actually very much based on DRA. And DRA, if you know, is also based on the PVC PV model. So pretty much like if you wanted to get like a high level summary of this, like a 100-foot view of this, pretty much this is like you could replace a lot of these boxes with PV and PVCs and like the CSI interface. Or DRA, it's the resource slices and resource claims and drivers. So it's pretty much the same thing. And I wanted to kind of explain this concept because I just thought the idea was interesting. So here's how it would look. Here's how the idea goes. So if you had this concept of a life cycle event, this would be like the equivalent of a PV, where PV is right saying that okay, we've got this storage I want to advertise, and equivalent of that is this. I call this life cycle event a node life cycle event. I don't know how I want to call this. I don't know if this name's a really good one or not, but this idea is that it's advertising that there's this event that has to happen, this life cycle event, and it has to happen on a node. And there's three important fields that I have here. I've got a start, drain started is just a string, an end, drain complete, and then a time, a timeout for this thing. And all that means is like this event has this name to start, it has this name to end, and it has this amount of time to go from the start to the end. Um, and that's all it is. And so that's effectively like a resource that we want to advertise. And so we advertise it, and so something needs to pick it up and actually do the work. So this this idea is that we would use the kubelet. We could use the kubelet to help us. Just like with PVCs, we could have like a thing called a claim, where it's like claiming this life cycle event. And I use very similar terms to TRA, like I call it a driver. In this example, I call it server-side kubectl drain, and this event is the one I listed above. And just like with the PVC, like a kubelet could claim this thing. And in order to claim this thing, you also, so I'll go move my mouse to the right side of the screen, is you need some sort of interface like with the kubelet to then register something that's able to actually do work. So like this, think of CSI and like the CSI driver or DRA, like you have vendor drivers and they register with the kubelet and they have work that they can do to sort of fulfill things that are being advertised. And so, like in this case, what I have is this daemon set. I have this thing called a lifecycle driver, and I call it server side kubectl drain. And in your mind, like I think the thing to picture here is this thing is like just a pod that does kubectl drain on the node. That's all it does. And it registered with the kubelet, and the kubelet claims this thing, that life cycle thing, and this life cycle thing is representation of an event. And when kubelet claims this thing, the lifecycle driver would get this start event, just like again, like a CSI, like kubelet claimed me, I should start doing something. And so imagine that the kubelet does the start, and the drivers does what it's supposed to do. Like it's in the case of CSI, it's going to start allocating storage, and the driver here, it's going to start doing a drain. and then there's an end to it, and then while it's going on, these events get published to the node. Go ahead. There's a question.
Yeah. So is this like an example, or this is like the main flow?
Um,
I mean,
I
why
think,
is
yeah, go ahead.
the like the kubelet the main component running the like the lifecycle event?
Oh, so this is so what I'm thinking here is that the component that's running the life cycle event would be the driver. The kubelet is just doing the coordination. Like it's doing the claim, it's doing like so. I think we had this problem in the past, or I guess what I'm trying to get at here with this with the kubelet is that where who owns the life cycle event, and that's the kubelet is answering the question. It's going to do the claim, and then the driver it'll pick who's going to own it, and the driver would be the one that's executing that.
I mean, is there a reason for it to be kubelet and not, for example, kube control manager? Like, do we need some like
Because yeah,
kubelet specific features?
I didn't. Sorry, were you asking? Do we need? Is there? Do we need to use the kubelet? Is that what you're asking?
Yes.
Um, I think I don't know. I mean, I like I said, I'm my my thought here is like I'm looking at what the PVCs did and claiming something. And what I liked about this model, like with the kubelet, and this is like from my studying this and why this was a design choice for like PVCs and DRA is this interaction with the kubelet being aware of like these resources, and then also its control over the node itself. So the reason to answer the question um, is that the kubelet will be acutely aware of like of these life cycle events as their as their claims. It has an interface to with its drivers that is defined and how those things should interact. And then it also has the ability to share this information on the node. So the idea is that it solves actually, or at least what I like about it is that it solves, I think, some of the challenges around permissions and publishing things on nodes. It solves one of the challenges with like ownership of life cycle events. Um, so it has some things that are appealing to it with similar problems that you'd see like with PVCs or DRA. So it was interesting. I thought it sort of fit some of the problems that we had. So I wanted to see how it would look.
Yeah, maybe you don't need to get caught up on the kubelet part yet. Like to me, it seems like it could be like one of the flows, but it might not be like the flow that we will always use. So, for example, let's say like we might plan like these life cycle events or these maintenances, as we said, like on for example, a set of nodes or like a set of resources that span across multiple nodes, or might not even be nodes. And then like the kubelet connection will be not so clear.
Right. Yeah. So that's where it gets. So there's some cases where it's harder, like where like the so that's why like this one, what I'm focused on is is okay, this kind of interaction here where there's a kubelet, like it provides some interesting things for us. But yeah, I don't know. I mean, I don't know if like the kubelet will be the here or not. It was an interesting concept.
Yeah, sure. Like, let's not dive in deep into that. Let's just say it's a kubelet or
Yeah.
KCM or some entity that. Yeah. Okay. So let's talk maybe a bit more about the lifecycle events.
Okay.
Uh,
Yeah.
like I'm still not getting the full picture. Uh, I mean, for example, let's say when we did the node maintenance, we had like these set of phases that we would be going over. So For example, like the cordon and the drain, and then maybe even some verification and or maybe some reboot. And these things might be like nice to have. Like it would be good for them to be pluggable. So how would lifecycle event or lifecycle events and claims like fit into these like like uh, propagation of like these states or phases after each other?
Yeah, okay. So there I've got a few. So I go next, I've got a planning picture which brings in some of the other pieces. So the only thing I wanted to get with this picture was that um is that like first of all it's like the similar to that PVC architecture and PV architecture. The events get published on the object, in this case the node. And then there's like a driver that's like the daemon set. That was kind of like where I wanted to go with this. But um the planning I have here next. So I think
Just a sec.
what
Yeah,
goes
let's
further.
let's let's go
Yes.
first for the first picture. Elmiko has a hand up.
Yeah, I just wanted to kind of add a question, I guess. Like when we start talking about phases and stuff like that, I start to get a little bit nervous. Looking at I'm appreciating the design you got going on here, Ryan. I think it's an interesting way to approach this, thinking about kind of the PVC, the CSI model and whatnot, for some of this stuff. But I'm wondering, like, on the I guess the life cycle claim would be the CR that would exist throughout this. Like, did you did you explore the concept of maybe like using conditions and whatnot on the claim to be able to highlight, what is currently happening in like rather than going through phases of like, oh, we're doing this, now we're doing this, now we're doing this. I wonder if we, maybe think about, like some sort of rich set of conditions that kind of can speak to what's happening during whatever the life cycling event that's going on is.
Yeah, so you mentioned conditions on the life cycle claim. What I was thinking is that, or at least what I've pictured here is that we that model of using conditions would exist, and but what they would do instead of being on the claim, they would be on the node. I mean, I don't really show it here. It's like that. It's so I call life cycle event. I don't know how to. The reason I left this a little bit vague is I don't know how exactly we do this, but theoretically, like the model you're talking about, a condition, what I'd expect to see is that, see this drain started cloud I have here and this drain complete. Those would be conditions that would get published to the node. So the idea was that someone could follow those, that life cycle on the objects that were actually life cycling.
Okay. So like I'm always looking at the node to see what's happening on the node. Like I'm kind of curious, like do we have a concept of the event, whatever the life cycling event going on, especially since we're calling out like a claim here and I'm guessing the events are just regular event objects, but like if we're calling out a claim, is there the notion of like an administrator observing the life cycle event differently than just looking at the node and the conditions on the node? And I'm gonna have to drop here shortly, unfortunately.
So I think what I'm targeting is that the administrator should be looking at the node. I think what I'm things I'm trying to solve is like how do we get those conditions to the node? How do we get them on the node? And like what's the APIs surrounding doing that? Like beyond just like someone putting it there, right? Because that's sort of the challenge, is that if someone just puts it there, right? Like how do we control who puts it there? When they put it there, what
Right,
order they
right.
put it there. Like there's so many problems in that area. So like that's a lot of what this is diagram is focused on, is like the conditions getting to the node, and that would be what is tracking the life cycle.
Okay. Yeah, I mean that makes sense to me. I think like if we talk about the notion of having like a separate CR associated with the life cycle event that's happening as well, I think that it's also an interesting pattern to explore because if I look at the node, like you were just saying, like how do I know who's put something there? How do I know, what's happening or whatever? But if I have a separate object associated with like just the life cycle event, then I know that like contextually everything's contained on that around the event that's happening. But I don't know if that's valuable to users or not. So I appreciate what's going on here. I just wanted to kind of share my 2 cents, I guess. And I'm gonna have to drop, unfortunately. But thanks, Ryan. I really appreciate the work you're doing here.
Thanks, Michael.
Thanks.
Felix, did you want to have more discussion about this before I scroll down? I wanted to answer
Yeah,
that question about plans.
yeah, I think like what Michael said is valuable. How we represent like the life cycle events. Like if we have a CR or if we have a list or a set or some kind of like deep status on the node, like that's still like valuable to resolve. But maybe can we focus like on the interactions? So let's say this is
Okay.
implemented somehow, the event. Yeah, I know like you want it to be this like to be more clear, like what's happening exactly where. So sorry that I'm just going, and this might not be a kubelet, and this might not be a life cycle event like on the node, or it could be a CR, but we have to like think of it as
No, it's okay.
like
I have kubelet there because it's the only way I can make it make sense when I put like driver over here and claim over here and say this is like PVC. So, but you're right. I would like to explore the different ideas, whether this is a kubelet or not. I think that's fine. So
yeah,
that's
yeah.
totally valid.
Okay, so cool. So like yeah, this is still like work in progress. But let's say like we want to choose this like event claim and driver model. Can you describe how would it work, for example, if we want to implement, for example, the kubectl drain and we want to do server-side one, how would you navigate like the whole flow?
Okay. Okay. So what I would expect. So I'll start with the end user, or maybe yeah, the developer who wants to implement server side drain. What I expect them to do is that they would build something that I describe here as or name a lifecycle driver. They would It would be a pod, and inside that pod, they would have to have the ability to register with the kubelet, however we define that. I don't know. Um, and then they would have to have the ability to respond to a start and an end life cycle event. And um, so that would, so when it starts, so when you get a start event, and again, very hand wavy, but if you had a start event given to you, that would mean that your lifecycle driver that you implemented for kubectl server-side kubectl drain would start running kubectl drain on the node. And you're a daemon set, you run local to the node. Your scope is going to be to run kubectl drain locally on your node. And then when you're done with the kubectl drain, however you define drain, however you would define satisfying that event in your driver, you would then signal end back to the kubelet, whatever that means. And when you did that, um, actually, before I do that, so that's how you implement it in the user, and that would be the interaction here on the bottom right. Um, okay, I'm gonna go to the lifecycle event then.
Oh,
Before,
okay, well,
yeah,
maybe can we stop first?
yes, go ahead.
Yeah, there is a lot of to unpack, and we will not solve it today, that's for sure.
Yeah,
But okay, so like 2 points. So I can see like two use cases where you might. So like the first question is like, does the lifecycle driver run like all the time or just during like the creation of the event or like the event like progression?
I think it would be around all the time.
Okay, so now you have like two use cases. One is some users might not want to run a driver on each node, like in their whole cluster. So you might have like two set of like requirements or like competing requirements. One is have just one driver per cluster running somewhere, not maybe as an even daemon set, like to not consume that many resources. And the second one is run it on the node with the kubelet or by the kubelet to basically achieve like the like most safe uh, drain as you can. So if the node gets disconnected, for example, due to some network errors or issues, you would still have the daemon set running locally, and it could perform the drain properly, even like on these nodes.
Yeah, so it's really good points. Yes, you'd be committed to running right way a pod on all the nodes and a pod that is running alongside the kubelet. So yeah, that would be one of the requirements that would have to be that would be required. And then the other one, which is absolutely like a challenge with this design, which is you have a daemon set. So um what if like what are the cases like we have problems on the node? Like like what if like you're trying to drain the node and I don't know like I mean we can come up with a million reasons, but your lifecycle driver's not running or the kubelet's not running or something that would go wrong anywhere in this interaction, right? Like how do you eventually resolve this? I mean, there isn't an answer for that. I think like here's an answer for that here on this side because this is very much tied to the node. But where there is an answer to this question is that because we're pushing events to the node, the idea is that and we have these claims externally. What we do have is enough information to understand what we would like to happen or what's supposed to be happening, right? Because you could look at this life cycle event, for example, you can see where it's supposed to start, where it's supposed to end, and how long it's going to take. You can also see the claim, and you can see whether the kubelet actually responded to this claim. And then you can also look at the node and say, okay, well, did it hit the start event? Did it hit the complete event? So you can find out where this thing is stuck in its life cycle or where it should be, where it is in this life cycle event. You should be able to figure that out. So what I'd expect is I have this box at the bottom of my screen. I have not talked about this at all yet, but this thing called lifecycle controllers. This is sort of I think the way out of dealing with this, where I fully expect that people will have some sort of controller that understands what is supposed to happen here and lives outside of this kubelet and outside of this daemon set, outside this node, and can look at what is supposed to be happening and make a judgment about what should be happening and could do something about fixing it. So it could be like so it's meant to deal with the corner case. Well, okay, well the kubelet's not working, the driver's not working, something is wrong at the communication. Go ahead, Philip.
Okay, and what like are the communication channels between the lifecycle controller and the driver node?
So what I expect the life cycle, so there isn't well, okay, so you could technically I don't think I'm gonna I don't think I could think of a um so okay, let me answer it this way. The lifecycle controller can do what it would like, and what I would expect is that it would be watching the node, probably the lifecycle event and the claim, um, and it would be making a judgment as to like where the life cycle event is and if it's stuck or whatever it needs to do. It is possible that the driver and the life cycle controllers have interaction here. Um, it's very possible to happen. Maybe they're checking in with each other. Maybe the life cycle driver is asking for help from the controller. I don't know. I guess the way I look at this life cycle controller is that it's sort of it's like our corner case fixer. It's like meant to be like it's very specific to the end user and their workload and how they want to handle um things that can't be solved by the driver on the node. And that could be anything. So they're this interaction, the lifecycle controller, I think it could be I don't know, it could be anything. I think it can interact with any of these objects. Go ahead.
Okay, so yeah, I will. Yeah, we can talk about that a bit more, but maybe Peter, do you have like some initial thoughts on this new like potential kubelet responsibility?
Yeah, that's a good question. I think I'm still sort of processing. I think it is. I mean, I do like the like reflection of the EVC and pattern. I think that that's like a commonly replicated one. But I think, yeah, I would need to think a little bit more through the scope change in Kuba. But I think it could be open to it. I think we probably just want like more of a conversation in Signode about it.
That's a good point. Like if like we want to be like serious with this approach, at least I mean kubelet could be substituted by something else, but yeah, it could be great to bring this to Signode and discuss it there. I mean, because like usually we try to like make the communication done through the kube API server because like that's the default thing. So now we are suggesting because we have like the driver and the controllers, they might live somewhere else. The driver will probably live on the node, right?
Yeah.
In some cases might not. And if we want to channel this through kubelet, it might work for some cases and not for others. Or I don't know if we can do like a dual communication because this is like a reliability problem. So maybe we could have communication both through the API server and also through the kubelet. Yeah, there is like a lot of open-ended questions.
Okay. I'll write some of these down, Philip, and think about it a little bit. So you're the I and one question for you, the API server communication path, this is the path that would probably not involve the kubelet, or is it that you're thinking
So
like
I
the
mean,
case
like
that I was
if
talking about with the
like
lifecycle
yes.
controller?
So for example, when I first mentioned that we might want to have one driver per cluster or per node, if you
Hmm.
have it per cluster, then you don't have like, or you probably don't have connection to the kubelet, and you need to go through the API server and the
Right.
lifecycle controllers as well. So if they might observe the node if the kubelet is responding or not, and then they might like to decide to reconcile somehow if, for example, the node, the communication gets broken, or if I don't know if the driver is maybe misconfigured and the lifecycle controller might need to decide to restart it and put a new version there.
Okay. Yeah, let me see if I can model that. I'll try and do that. And that's like an alternative, I think, where so would it be, I guess one life cycle driver, I guess is what it would be. Something that's really all powerful, that's controlling
Yeah,
a
I
lot of
think
different
like
things.
it would be good to explore like both paths. If the lifecycle
Okay.
driver is on the node and if it's outside, and see like if we can like support both of these use cases or see like which like if the first version or the second one, what kind of things it would support. And then
Okay.
we can bring it to Signode and tell them like these are the advantages of having it collocated and these are the disadvantages. And then we can go like by one by one and say like, if it is a good like approach to choose.
Okay. That sounds good. Okay, I can model that. All right. Do you feel like we're okay to scroll down here, or am I going to overwhelm people?
Maybe just wait a bit more. Yeah, like yeah, I don't know, like how deep we want to go. Like let's first try to concentrate on the scope we have. Um, so how do you expect like the ownership to be propagated? So like let's say you have lifecycle event and you have, for example, two drivers, or we might need like a default driver or like a default behavior which we would like to ship with Kubernetes. So for example, the kubectl drain or the graceful shutdown. Yeah, how would we how should this be like the ownership be solved like in this model?
Ownership is in like who should be acting on
Yeah,
graceful no
like
shutdown? Okay.
actors. Yeah,
Okay. So what I'm thinking, so in this model, what my thought um, is that kubelet would help us solve the ownership problem by being so the end user would choose So the end user is choosing the driver. So the end user is going to choose the owner. And then the kubelet is going to be handling the, I guess, the handshake, for lack of a better word, to choose like, okay, um, this is what we're going to claim as the owner, right? So it's going to claim, okay, well, I would like, so I guess the way I have it in this lifecycle claim is that I would like, I'm doing no drain. That's my event. My driver, the thing that's going to implement no drain, is this thing called server-side no drain. And then my kubelet is going to claim that that driver is going to implement that event. So it handles the case where you might have to do no drain, and we don't know who is going to be the one that's going to be executing no drain. So kubelet is going to select the driver. Yeah, go ahead. Question.
Okay, so kubelet or the user, the admin in this case.
Oh, sorry. So maybe I didn't say that right. So the admin is going to choose which of them is going to which driver is going to operate on this event, and then the kubelet is going to execute and actually like validate that that is the one that's going to, because so for example, like I could have several of these claims, like I could have like many of these claims, and they're all could say like I want to do no drain, like pick me. Um so who is doing the no drain? So Cuba is going to claim one of these, and um, that is what will execute the no drain. So you should be able to say like you should be able to take if you were watching this by doing lookups on the API, you should be able to look at this and say, okay, I know what the lifecycle event is. It's no drain. I'll know who is going to be um, executing that lifecycle event. That's the driver. And then I'll know which driver because that one will be claimed by the kubelet.
Okay, so I think like there are a couple of issues. One is, so what if we have like competing claims for the same event, and do they have to be exclusive?
Exclusive. I'm trying to understand by what you mean by that. Like they,
If like multiple claims to be assigned to the same event, like to maybe run them in parallel.
okay. So I'm thinking that that only. So I'm thinking back to like the PVC model where like the event is the PV and like we only have so much storage, and the claim is going to claim like the whole storage that the PV
Yeah,
is.
okay, I understand, but in this case, it might not be exclusive. So we might have like, because, yeah, like, yeah, this is just one thing to consider. And the second one
Yeah.
is, like, it might be difficult for the user or the admin to select the driver. And it also depends. I guess you could frame it as we could have like different kind of node drains, because not every node drain should have like the same driver. And either you like create special node drain type for each like different kind of drain. And for example, like the kubectl drain would use one like type of event, for example, like server-side drain, and then kubelet would use like a different kind of drain for the graceful node shutdown. So, like, yeah, my question is, how should we like design the API to solve like these different use cases for drains, and also like decouple it from the user. So from the user perspective, it should be, or I mean, yeah, or yeah, who is actually like
Maybe is it you
who
want?
is, yeah.
I was gonna say maybe I was trying to see if I can try and help with the question. Like, is it that you're worried like the admin has to select a bunch of different drivers? Like, there's a bunch of different drivers out there, and the user needs to pick like which is the right one for their use case. And that's like what I is that what you're saying? Like is one of the challenges?
Like my question is how should the nuances get propagated? So we have like some setting you want to do. So this is like the event. You have a drain, for example, like
Mhm.
the but you might want to like decide what kind of drain it will be like from the event originally. Like
I don't know what you mean by what kind of drain. Like so like um I guess so you could maybe let's see if this helps. You could this node lifecycle event thing is user defined. I don't. There might be other types of node drain, and maybe that's actually what kind of the is your question is like some of the challenges, the nuances, and that needs to be user defined. Yeah, yeah, I don't know. This you could change this what I call a lifecycle event. It could be node something drain, special drain, node. I don't know. It could be something else. There were some questions in chat. And there could be multiple drivers that are relevant. Um, oh, thanks for attending that. So yeah, there absolutely could be multiple drivers that are relevant. Yeah, so I don't want to scroll down, but I was going to show another one. Like you could, yeah, you could. I mean, I tried the kubectl drain one, server side one. I showed here because it's something that I think always is requested as a feature, um, and I guess it's like the simplest form that we do drain today. But yeah, I mean, you could do once you this is like a pod and it's running and it has an interface. I mean, yeah, I mean, there's many drivers you could pick. Your driver can do anything. I mean, once you would write the code, the end user. So I mean, you define drain whatever you want. I mean, you could reach out to the lifecycle controller and say, "Hey, can you drain me?" Like, you don't even have to do any draining here if you don't want to. There's lots of things you can do. I don't really know, but I think the only thing I'm trying to illustrate is that there's an interface here that's defined, and that's expressed on an API. Yeah, so I guess what I'd argue is that it's absolutely there's a challenge in like the user picking the right driver and the right event. That has challenges. It's also could be a good thing. I mean, that's one of our challenges that I think we want to address is the ecosystem and like the fragmentation. Um, I mean, you could theoretically have an ecosystem of drivers, just like again, like what I was thinking here was like with PVCs and DRA, they have a whole ecosystem of drivers that you'd pick from. Um, we'd let end users define those things and document them, and let the end users who wrote those things be responsible for advertising what those drivers are and how they work. Um, and then, yeah, I mean, the other question is UX. Like, I don't know, like, if with how that should be exposed, but that's something that could be solvable.
yeah, I think maybe we are getting like the roles mixed a bit here. So I suppose like the claim itself could be like like discoverable or resolvable by some controller. So it might not be like necessarily an admin because like in the end we want this API to be simple. So like if you have a user today who just has a node and does and isn't maybe clear what all of like the components are running in the cluster or on the node and just want to drain the node so it can be like terminated, then like the person might not know like what kind of drivers are possible and what kind of drivers should be selected.
Yeah, I don't have a disagreement on that. I agree. I think that is a challenge for sure. Um, yeah, I mean, like I said, I think the only counter to that I can think of is that so that would be a con. I would agree. It's definitely a con. A pro is that I think the is that it would depend on the driver author and how they document this stuff and how they would want this stuff to be exposed um and the ecosystem for that stuff.
Yeah, like don't take me wrong, like I think like it would be like a great option like if we have this option and we could set the driver which we want, even like override maybe the default one,
Hmm.
like but we should also like focus like on the default path and like if we just want to say, I want this node, all of the pods from this node to be gone, and I don't care how it happens. And then you have some machinery in the background, like kubelet
Mhm.
drivers, controllers, and they do all the thing, but without like much user input.
Yeah. Okay, so maybe what comes to mind when you say that is like the kubectl drain command. Like if like because you could solve that today. I think what you said, the use case with kubectl drain, it's that what are you getting? What else are you getting, or what are you not getting actually with kubectl drain? Like I guess what I'm saying is I'm not trying. I wouldn't say this is going to try and replace kubectl drain. I think I would look at it as um, an enhancement to kubectl. I guess it's about observability. It's the observability part of it that when you run kubectl drain, um, can you write a controller that has an API that describes what's happening in kubectl drain? I mean, you could, but you would require CRDs, and then like how does that integrate in the ecosystem? Um, so I think that what I'm after here is like that it's the basic case, like you said. I feel like this wouldn't make sense, but it's the case where you want more observability on what you're doing. Okay, we're at time. This was a really good discussion. So thank you very much. I'm sorry I took the whole time. Hopefully there wasn't another topic that was added, but um I let's continue to discuss this. I think I'd love to talk about this offline if people have more comments, and then um yeah, and then we can come back and review this again and see what people think.
Yeah, thanks, Ryan. I think it's a very interesting approach to this. And I guess like we did not have a chance like to do much progress today, but I mean there were a lot of open questions. So we did progress, but we need like some answers. So like to me it seems like it would be great like if we could show like two use cases. One is the default one. So for example, you do the like server side drain like that you would like bundle with Kubernetes, and the second like is the extensibility. So you have like your own custom drivers, and how would that all interact? So for example, if you want to preempt the default behavior, etc. So like if you could have like two use cases that are clear, like we can imagine like which part goes where, and also try to maybe define better the personas, so like we know what the admin does, or if we have some like controllers behind.
Yeah, makes sense. Okay. Yeah, I mean, I'll take the feedback. Let me make some changes and we can talk again. I think we can probably continue the discussion next week, and we can if people are interested. I think there's definitely a lot of context here. Like I think this isn't like a diagram that has, like you said, there's a lot of questions. There's a lot happening here. Um, if you have questions about the stuff, like let's talk about it over Slack, and then hopefully next meeting, like I can try and address as many questions about the context, um, and see if what else, how else we can make progress on this. Okay.
Sounds great. Thanks everyone.
Thank you.
Bye.